Now, let's see examples of homogeneous mixture. The word homo means the same. So, as we have seen previously, a mixture which has the same uniform composition throughout its mass is what we call homogeneous. For example, when you mix salt and water, they mix completely, as you can see. You can't spot the particles. That is a homogeneous mixture. Uniform composition. Another example is a vinegar. Another example can be alcohol and water. Another example can be a carbonated drink. Another example of homogeneous can be an orange juice. Let's see others. Yes, you can see sea water is also an example of homogeneous. Air is example of homogeneous. Also, sugar mixed with water is an example of homogeneous mixture. Coffee is example of homogeneous. A coin is also example of homogeneous mixture. Let's now check heterogeneous mixtures. The term hetero means different. So heterogeneous mixture is a mixture which is different or is a non-uniform composition throughout its mass. Let's see examples. If you mix water and sand, that is heterogeneous mixture. Let's see other examples because sand can settle down and you can see separately where is water and where is sand. Let's see other examples of heterogeneous mixtures. Okay, if you have oil and water, that is a heterogeneous mixture. If you have ice cubes and cola, that is also a heterogeneous mixture. Tomato ketchup is also an example. Also, chocolate chips is another example. If you have chicken noodles soup, that is example of heterogeneous. If you have a pizza, that is also another example. If you have apple juice pulp, that is also heterogeneous mixture. If you have salad, that is also heterogeneous mixture. And if you have sandwich, is also example of heterogeneous mixture. Keep watching. Yeah, let's now check the differences between a compound and a mixture. Let's start with the compound. Two or more elements combine together chemically. For example, if you have hydrogen and oxygen elements, if you combine them, you get water, as you can see. But for the case of a mixture, two or more substances combine together physically. For example, table salt and water. If you combine them, you get a solution. Copper and tin can also combine together to give alloy. Another difference is that particles lose their original properties in compounds. For example, hydrogen and gases and oxygen are gases. They combine to give water, and the water is a liquid. So it has lost its original property. For the mixture, particles retain their original properties. If you have maybe water and pebbles, each has its own property. Again, the compound forms homogeneous composition. You cannot spot particles when you have maybe something which is mixed completely, and the mixture usually is a heterogeneous composition. You can still spot the particles in the mixture. Also, in the compound, components cannot be separated by physical means. For example, you cannot separate water back to hydrogen and oxygen, but components in the mixture can be separated by physical means. For example, you can separate water from pebble by just filtration. Also, every compound has its own chemical formula. For example, water, that is the formula for water, but the mixture has no chemical formula. That is a sugar solution which does not contain or have any formula. Compound has fixed composition by mass. For example, water molecule has 2 molecules of hydrogen and 1 molecule of oxygen. If you try to add more molecules of oxygen, you get something else, which is hydrogen peroxide. But for the case of a mixture, it has no fixed decomposition by mass. For example, sugar and water. You can add large or small amount of sugar. Another difference is that the compound has fixed and sharp melting point, while the mixture have no fixed. In the table given, it shows the differences between a mixture and the compounds. They are just the same as the previous ones, which we have seen in that previous video. So keep reading and make some notes so that you can understand it clearly. They are just similar. Keep reading. Okay, now liquid mixtures can be described as solutions, suspensions, or emulsions, depending on their composition. Let's start with solutions. What is a solution? A solution is a type of mixture where different substances are combined evenly, creating a uniform mixture. A solution consists of 2 main categories, which we call the solvent and the solute. Let's see what they mean. Okay, let's now start with a solvent. A solvent is the part of the solution that can dissolve other substances, and it forms the major part of the mixture. On the other hand, a solute is the substance that can dissolve in a solvent. For example, salt, and it is usually present in small amounts. For example, when you mix sugar with the water, you can create a solution where sugar acts as a solute while the water serves as a solvent. This type of combination results in a so-called homogeneous sugar-water mixture. Hope you remember the meaning of homogeneous. Okay, let's now see the illustration of solution, solvent, and a solute. As you can see from the screen, we have water, which acts as a solvent. A solvent is something that can dissolve other substances. We have sugar on the right, which acts as a solute. A solute is something that can dissolve in a solvent. So if you mix them together, you get something which we call a solution. So a solution is a combination of solvent and solute. Now let's try mixing the two. Just pick small amount of sugar and mix with the water. When you stir them, they will mix completely to form a homogeneous mixture. That is what we call a solution. Now, a solution can be in different types based on the amount of solute that can be dissolved in a solvent. Let's see the main types. Let's start with unsaturated solution. What is it? This is the solution in which the solvent has not yet dissolved the maximum amount of solute that it can hold. So, in simple terms, unsaturated solution means there is still a room for more solute to be added in a solvent, and the solvent can still dissolve more solute. The second type is a saturated solution. This is the one where the solvent has dissolved the maximum amount of solute that it can hold at a specific temperature and pressure. This means that if you keep adding more solute to the saturated solution, the solute will not dissolve. It will just settle at the bottom. A third type is supersaturated solution. This occurs when the solvent holds more solute than it can dissolve at a given temperature and pressure. This is a very unstable state and can usually happen when you dissolve a solute at an elevated temperature and then you cool the solution down slowly. Usually, in a supersaturated solution, the solute might start to crystallize out if it is disturbed. These distinctions of solutions are very important in various scientific and practical applications, particularly in the fields like chemistry and cooking.